Humidity is a measure of the amount of water vapor that's present in the atmosphere, and that depends on the temperature. Warm air is capable of holding more water vapor than cold air. And so when moist, warm air cools down, we get condensation occurring. You see that, for example, in our homes in the wintertime when the warm air condenses on the colder windows. We get condensation occurring. The term that we commonly use is the term relative humidity. And relative humidity is abbreviated RH, and that is a measure of the actual moisture content of the air over the maximum content of water vapor at a given temperature. And we make that a percent. So we have then the actual amount over what the air is capable of holding at a given temperature, and we call that relative humidity. When the relative humidity is 100%, that means that water can no longer evaporate. And as a result, you feel rather clammy because your skin sweats, but it can't get rid of the moisture because the moisture doesn't evaporate. If the relative humidity is very low, we feel kind of chilly and our skin starts to feel dry because the water is evaporating so rapidly from our skin. So how do we measure relative humidity? Well, one way is to use two thermometers. One is, we call a dry bulb, and the second is a wet bulb. And so we take the thermometer and we dip the bulb in some water. The water will now evaporate from the wick, and I've just used here some gauze from the first aid kit and taped that onto the bottom of my thermometer so the bulb itself is covered with the gauze. Initially, both thermometers read 23 degrees Celsius. Now what we'll do is move them rapidly in the air. If the air is quite dry, then water will evaporate rapidly from the wick, which causes a cooling effect. If the air is very humid, the water doesn't evaporate rapidly, and as a result, we have less cooling. So we do that for a while, and then we record the temperatures. So my one temperature is 16 degrees, the other is 23 degrees. So we have 16 and 23. Then we need to go to a chart to look up the relative humidity. So here's an example of a chart that is available from various sites on the internet or textbooks. And we then go to the difference between the dry and wet bulb. So that was 16 degrees for the wet bulb, 23 for the dry bulb, a difference of 7 degrees. So we go down the column 7 degrees, and we go to the dry bulb temperature, which was 23, and we find that the relative humidity is then 48%. And you can see that as the temperature difference gets smaller, the relative humidity is higher because the water doesn't evaporate as rapidly from the wick, and therefore it doesn't create as much of a cooling effect. If the relative humidity is low, then we get a greater difference between the wet and dry bulb, because the water is evaporating more rapidly. You can also purchase an instrument for measuring the relative humidity. This is called a Sling Psychrometer. A Sling Psychrometer. It has a cap at the end that unscrews with a wick in it that you add water to. So I've added some water to that already. You pull this portion out, and we have then a wet bulb. So here we have a wick that's been made wet, and on the other side we have a dry bulb thermometer. And the way you use this is, just as the name implies, you sling it. So you twirl it around like this. And as you twirl it around, the moisture will again evaporate from the wet bulb, the wick, causing a cooling effect, whereas the dry bulb is not affected by twirling it in the air, and hence it remains the same temperature throughout. We do this for about a minute or so, and then we stop it and we record then the two temperatures. My wet bulb in this case is about 16 degrees, the dry bulb is 23. Well, that's exactly what we had before. This instrument also has a built-in scale that we can then use. And we can slide the movable portion in and out, and we match up the proper temperature. So we had 16 degrees and 23. So we have the wet bulb and the dry bulb together, and that gives me a relative humidity of about 48%. Very close to what we had before. So this is called a Sling Psychrometer. It's an instrument then that we can take into the field or into the classroom, different parts of the school, for example, and we can measure the relative humidity with this